Hi and welcome to this quick how to help video on completing the square. We're going to be looking at a way of rewriting a quadratic. In the exam, they will use a kind of general form to encourage you to use completing the square. So they're never going to actually use those words, completing the square. They are going to ask you to express it in the form of x plus a all squared plus b. And that's the general form for completing the square. So when you see that, it should trigger this method. Sometimes they do use P and Q. So, you know, that could be what you see. But either way, it's going to look like that. Okay. So if I've got a quadratic, let's say I've got x squared plus 12x plus 3. When they're asking me to write it in this form, they're asking me to rewrite this, but it needs to remain equivalent. So it's going to be an equivalent equation. It's going to be doing the same job, but it is written in a different form. Okay. This is how we do it. We look at the first two terms and we separate them into a single bracket. The first term, x squared, is going to be written as just x. So it's like it's been reduced down by a power. I've gone from x to the power of 2 to x to the power of 1. Okay. The next term, I always half whatever number I've been given in front of the set of the x. So this is going to give me 6. And then the exact same thing is actually happening to the x. The x here is x to the power 1. Now, if I reduce it down by 1, like I did here, x to the power of 2 reduced down by 1, I've got x to the 1. Here I've got x to the 1. Reduced down, it would create me x to the 0. And anything to the 0 is 1, so it disappears and it just leaves me the x. So there's nothing to squeeze in, it leaves me the x. I'm going to close that bracket. And then I'm going to put the power here. And that is the first step of any question. So if I had, I don't know, x squared plus 10x and whatever on the end, this bit here would become x plus 5 squared. If I had x squared plus, I don't know, 6x and on, I would be getting x plus 3 squared. And so on. Okay, so that first step is really, really nice and simple. Now, if I do what this piece of algebra tells me to do, x plus 6 squared, then I'm going to have x plus 6 multiplied by itself, x plus 6. If I Crab's claw this out, I'm going to get x squared plus 6x plus 6x plus 36, collect up my middle, and I've got x squared plus 12x plus 36. So this part of my Crab's claw is perfect, matches, and therefore is equivalent to the original quadratic that I was given. My problem, however, is this last step of the Crab's claw, 6 times 6, it gives me 36. I do not have a match. I've got 36 and I want 3. So they really are very different. So I'm going to write literally that down. So this is my adjusting stage. Let's say I've got 36. I want 3. How do I get from 3 to 30? Sorry, how do I get from 36 to 3? I take away 33, and that's the adjusting. That's the number I need to use. So my final answer is x plus 6 squared with my adjustment, and that there will work perfectly to create that there. So they become equivalent. Okay. And those steps don't don't deviate, they don't change because the question looks different. It is always that same approach. I'm going to do one more, just one that's slightly harder, and so that you get to see it a second time. So we've got x squared minus 5x plus 2. Hopefully you can already see why this one is going to be harder. It's going to be harder because we are going to be working with a fraction. So when I work on this bit here, I've got my x minus, and then I've got to do 5 divided by 2. Okay, now it could be quite tempting to actually do 5 divided by 2. It's a fairly easy, straightforward decimal for us to get to. Decimals can generally be an individual's sort of comfort zone. They prefer to work in the decimals, so it feels very natural to want to do that. I would discourage it because not all decimals are easier to work in. Fractions are the standard notation that we use for this type of work, and with confidence, it's really quite easy to work in the fractions, whereas some decimals can be quite hard to work in. And these, whilst this particular example is fairly straightforward, and you might be a bit like, really, I think I can manage in decimals, they won't always work out that way. So it does come with a caveat, okay? So we're staying in fractions because that is what we should really be doing. I'm not going to crab's claw the whole thing out. I don't need to. I know that the whole crab's clawing will recreate me this bit apart from the very last step. So I'm literally just going to do the very last step, which is 5 over 2 times 5 over 2. That is going to give me 25 over 4. So I've got 25 over 4. I want 2. Now there's 2 ways of doing this. You could either change this into a mixed number so that you can work out the difference, or you can change this into a fraction so you can work out the difference. It really doesn't make any difference. You kind of do what's natural to you. For me, I would change this into 8 over 4. And then I would say, right, I've got 25 over 4. I want 8 over 4. I've only got to look at the difference in the numerators. Really easy for me to see that I need to take away 17. So take away 17 over 4. And my final answer is x minus 5 over 2 all squared, with my adjustment of minus 17 over 4 to keep it equivalent. And that's it. That is completing the square. It's completing the square when you have been given a quadratic where the a value is 1. So if I had a 4 or a 3 or something in front of here, then there is an extra layer of difficulty that comes into the problem. I would put that into a completely different video for you so that you can see how that works. But these questions are the most common, and they're the ones that you want to get nailed first before you worry about anything else. Okay, so I hope that you have found this useful, and I look forward to helping you in the future. Thank you for watching.